I'm also going to go over, like with most problems, I'll go over how you should address the problem. And then a lot of times I'll also go over, if you didn't know that, but you would know a little bit, this is where you should have started or at least gotten to. So I'll talk about problems in a bunch of different ways. Some problems concern me more than others, that they're in this list of top problems with, but for different reasons. So this, number 30, is the most missed problem. And it is not that hard of a problem, but I'm not concerned with this one. Because I think the wording of this problem is confusing and doesn't get you to where you need to be, but once you get to where you need to be, then this conceptually is a very easy problem. Alright, so delivery service places package into large containers for flying across country. Suppose they always transport 2 on each flight. The 2 containers are chosen.
Should we write like contextual stuff, or should it just be generalized?
It's absolutely up to you. I'm gonna write a lot of both on the board, and it's totally up to you. Yeah.
We get to take our test.
Yeah, so I'm not gonna take your test back at all now. Like I have everything I need. You can write on your test, and I don't mind if you do, but remember when I'm going through and checking your stuff, like I need to see it's on notebook paper. It's like marking all over this is fine. Just make sure you also write on notebook paper. So 2 containers are chosen, so their combined weight is close to, but does not exceed a specified weight limit. So there's something that they want to get close to, but not go over. A random sample of flights from these containers is taken. Might be important. And the weight of each of the 2 containers is reported. So the weights of the 2 containers are something. Well, I'm going to look at answer choices and give myself a little bit of direction here. What are all these generally talking about? So I need to think about correlation. So I'm going to write some side note stuff about correlation first. What is correlation? Symbol. Alright. What are the possible values of R? So -1 to 1, which is 0 to 1, and positive negative. And then it generally follows this scale from -1 to 1 to where numbers that are around here are considered what? No correlation, or the closer to the middle, I guess, should say weak. So 0 would be none. Here would be weak. Something out here would be considered what? And then all of these are obviously negative. All of these are positive. So R tells us strength and direction. So is this question asking us about strength or direction? Direction. So let's think about what direction actually means. So let's say we have a positive R. Positive R would be as one thing increases what? The other one also increases. A negative R would mean instead what? As A increases, B decreases. So they change the same or they change opposite. Height and weight, positive or negative? Positive. As you get taller, you're going to weigh more. You could do something really obvious and do money spent and money left would be negative. As you spend more money, you have less left. Alright, so this almost gets us to where the problem gets easy, but we're still not there yet. This is just kind of background stuff, and then all of a sudden it'll click with why this problem is supposed to be easy. I'm gonna clear everything I have written just to have more room. Alright, so we measured two things, the two containers. So I have container 1 and container 2. What do I know about container 1 and container 2? Alright, so let's come up with something easy and say we want the weight limit to be like 100. So if container 1 is I want to write combined weight of 100, but I don't really have much room. So if you're doing notes, combined to equal 100. Alright, so I'm just going to write down some numbers for what container 1 could be. Container 1 could be 30, 50, 60. If container 1 is 30, how big can container 2 be? Container 1 is 50, how big can container 2 be? And then my last one? So as my container 1 increases, what happens to container 2? And I think it was hard in the wording to understand that that's what the problem was asking. But once you thought about it that way, then this is an easy problem. Obviously, as the bigger my container 1 is, the smaller my container 2 has to be, which means the answer is what? Oh, and that's another thing. I purposely did not tell you which problems you got right or wrong, or how many you got right or wrong. I think you pay attention more, and a lot of times people, if they got it right, they're not going to listen to that problem. But I go over a lot more than just the problem, so I don't want to do it that way. And another thing that I should have said last class, I didn't think about it this way. I think I had some people leaving really deflated because we went over 6 problems, but I went over the most missed 6 problems. So if you leave this room today not getting a single question right, that's probably fine. Like we're going over the hardest ones first. And I didn't think to tell that to my last class before somebody made a comment. So be okay if you don't do very well once we go today.
I have a question.
Yes.
How do you know that we were trying to determine which direction we're going with this?
Okay, because of my answer choices here being, okay, I'm in the middle, I'm at the end, or this, instead of saying strongly. So I use my answer choices to go backwards.
Did you choose 100 or 100?
Yeah, I could have used whatever I wanted there.
Do you want us to put the correct answers on this folder?
Like it's yours now for whatever you want to review. So. And like I said, if this sparks any kind of question with material, this is just a structure, so just stop me whenever. Alright, so going to number 34. I think I'm going to start this problem with an idea instead of how to answer it. So researchers conducted a survey using a simple random sample of 50 registered voters to create a confidence interval on a test to estimate the proportions of registered voters favoring the election of a certain candidate for mayor. So assume the sample proportion does not change. That's actually extremely, extremely important, but most of you probably won't pay attention to or think about that. Which of the following best describes the anticipated effect on the width if the survey were to if they were to survey 200 as opposed to 50? So I'm changing what? I'm changing my N the question wants to know what's going to happen to my width. So you definitely need to get to the point where you can say, okay, I know what the question is asking. All right, so I'm going to start this problem as I am so confused and I have no idea where to start. How is my width, how is my sample size changing? Which is my old sample size was what? My new sample size is, so my sample size is what? Increasing. This is the concept you have to know. As sample size increases, or n increases, you need to know what happens. So in general, the confidence interval or the, oh, here's, what else can I call it? What's this problem asking about? Width. What's another general way? You just sit anywhere. And you need a weight sheet. Yeah, just write weight sheet off of one of them.
But I'll put it anywhere you want to. Where are the elections?
There's one on that middle desk. They were supposed to be on all desks, but I'm moving around.
Oh, okay.
And I don't care what it says. Okay, as the sample size increases, the width of the confidence interval, what's my generic word for that? Another S word? Which is standard deviation.
Hey, nice.
So as your sample size increases, your spread does what? Decreases. You have to know that. In the first 6 questions, that comes, or first 8 or so questions, that comes up twice. So let's say that's all I can come to right now, and I have no idea where to go from there. Well, here, the new interval is a fourth, the new interval is a half, the new interval is the same, new interval is twice, new interval is 4 times. I am now down to 2 answer choices just because I know this, and I've not done anything yet. And that part, I need you to know how to at least get there. Now from there, I'm going to get into actually solving it. Let's write, so this is not necessary, you don't have to write this part, but I want to talk about it. What is our equation for confidence interval for one proportion?
In terms of money.
P hat plus or minus?
V square root of P hat plus P hat minus 1 grand, or 1 minus 2.
On your orange sheet, this equation is not on there, but one that is close is on there. Oh, it doesn't give the actual equation, but it gives you like the sample proportion being square root of P, 1 minus P over N.
Oh, yeah.
So like you can use some of those help if you get stuck. So if I am changing sample size out of this entire question, or out of this entire equation, what's the only part I want to change? I'm just changing this part right here. So I just want to look at something under the square root on the bottom of a fraction. So in the equation, this was in the square root, the bottom of the fraction. My new one is in the square root at the bottom of the fraction. This part up here is saying, assuming the proportion does not change. So whatever was here in the first one is here in the second one. Now I can find numbers and plug them in, but if they're not going to change, do I care what they are? So let's just call it 1 to make it easier on us. So now type in, what is square root of 1 over 50? The square root of 1 over 50 gives us what? And And what is the square root of 1 over 200? So is that half or is that a fourth? Now, there is a way to answer this problem that some of you did during the chapter that you probably forgot about. When I go from 50 to 200, how did my sample size change? Multiply by 4. Which means, how does my standard deviation change?
It doesn't.
Take these and then orange and then white and then go sit in the hall and start working. If you multiply the sample size by A, that means we dealt with this before. So if you made it 9 times bigger, you reduce your standard deviation by a third. And in that chapter, a lot more of you went this direction because that's all we were dealing with was that chapter. On the AP exam, I probably wouldn't expect you to memorize this. I would expect you to be able to get there with this. Like this is a lot more likely than that. But worst case scenario, you need to be with me at the beginning. Because like you can see that that's twice as much. Like I can literally type in this divided by that, and I just went, yes, I didn't make that connection. Oh, I didn't talk about one other thing in the beginning of your class. Maybe I was missing something. I tend to overlook things that I think don't need to be discussed. But maybe I should. You get the Z table, the T table, the equation sheet, all that on your exam. But there is no sheet on the exam that is green. There is no sheet on the exam that is purple. There's no sheet on the exam that is orange. I do them in my colors so that we can know which one it is, and I can tell which one you have out. But I have had someone who got to the AP exam before, looked through it, said, there's no green sheet, I don't know what to do, and never found it and never used it. So I need you to know things that I don't think I need to say. They're not those colors on the AP exam. And I'll go through this a little bit more, but it's just like a typical standardized test where like all the equations are in the back, I think, or the front. This was last year's. They had to modify it last year. It looks more like your orange sheet. But they do like all the equations first, and then they go, here's your Z table. I printed your Z table as 2 of them on one sheet, but theirs is the left side is the negatives are on the front and the positives are on the other side. So that's the left half of Z, the right half of Z. There is T, and there is technically chi-squared. I never even showed you this chart because I don't think there's any reason to do it because our calculator does everything. Technically, you could have used this and gotten the same thing. But so this is the way that it looks in your exam. They're not in color. Just making sure we address that. Next one is number 21. This problem, I'm not surprised at all that it is one of our most missed problems. But some of the things that you didn't know at this point within this problem probably concern me a little bit. Just because you need to know these, but us covering them now is fine. Like, it's been a while since you've done this. Okay. An experiment has 3 mutually exclusive outcomes. What does it mean to be mutually exclusive? So if I do this, do I draw circles that overlap or don't? I said just so we get our concept, it's going to be something like this. And it gives you numbers for them. I can write those right now. I'm going to start with 2. Probability of A and B. So if 2 events are mutually exclusive, can you be both at the same time? No. So if I can't be A and B at the same time, then my probability of A and B is what? And that's what that one means.
That's the one that I said. Wait, what did you just say then?
If they're mutually exclusive, they can't happen at the same time. If they can't happen at the same time, the probability of A and B is 0. Now this second one, and I want to show you this on your equation sheet so that we're looking at the same thing. Look on the side of your equation sheet that's not like boxes and find something that looks at least similar to this. What does it start with? And then so the U thing, just so as a reminder, means or. And so then it says probability of A plus probability of B, but then what?
Minus.
Now this equation is for what kind of events? And you should be able to see the difference because of what we just said here. So if they are mutually exclusive, what of this does not apply? Because it's what?
Zero.
So this part is all that we need if they are mutually exclusive. So is 3 correct? Because the two events are mutually exclusive. So to get A or B, I just add, or probably B or C, I just add B plus C. So 2 and 3 are both correct. Again, if you have questions, stop me as I'm going, I don't mind. So 1 is where I would not be surprised where most of the issues are, especially since I just threw a test on you and didn't say like, hey, go study for it or anything. So if A and C are independent, how do I check to see if they are?
A and C over B and C.
You're using that, but I don't want to say anything. So what you're saying is right, but I don't want to get that context.
Probability that C happens after A.
Given, yeah, which is under the assumption that. So probability that A happens given C.
Wait, look at the, no, she's saying something that
So this is the equation of what you're seeing. That's what I'll say. I didn't want to answer that. This would be equal to what if they are independent? That's just the equation part. So if I am independent, I don't care what you do, I'm going to be the same. Is it the same? Probability of me doing something is going to be the same as probability of me doing something given that you did something else. I don't care what you did, I'm doing the same thing. So now on, this is a concept that you'll need. This is one that is important that you will see. Alright, so now let's go back to it and think it applied to this problem. Probability of A given C. So given that I'm in this circle, what's the probability that I'm at A?
Zero.
What is the probability of A?
12.
Not 0. So they're not independent. So our answer ends up being B.
Can you do an example of the given
probability was they are,
Yes. Yeah. Yeah. And I'm gonna do it in a way that might not be like a write-out thing, but I think it'll answer your question, then if not, then I'll go from there. Alright, so she asked about, she wants to see a given thing kind of written out. I'm gonna do an example here. What is dang it. Not thinking through this. I know I need to switch. Okay, yeah. What is the probability that it is red, given that it's a circle? So how many of them are a circle? And how many of them are red? Alright, so I want to know if this is the same as this, or how many of these are red? Out of how many? Which is what? So in this case, circle and red are independent. Does that answer what you were asking me to do? And if not, I'll do more, but that was good.
so like you do, like if it's A given B, you do A divided by
A out of the total of B, yes. Alright, number 16. This one does not require much conversation. You either know this or you don't. I'm not surprised that a lot of people miss this, but once I tell you this, you should know not to do this anymore. So how do I find, like, conceptually, how do I find me? Add them all up and divide by how many there are. So if I've got somebody who has a class full right here, they just donated money, I can find that me because they can add up their money and divide by how many there are. I got a class full over here, they donated money, I can add them up, divide by how many there are, and find separate averages, right? Can I put their money together and find out the overall average of those classes? Add the money and then divide it by all the people, right? And I can do that if all that I told you was, this is how many were in this class, and this is what their mean was, this is how many is in this class, this is what their mean is. That's all you need to do that equation backwards. So, of those answer choices, which one of them would find me the mean?
Okay, and then so,
Yes.
right?
Alright, so which one of those is the equation of finding the combined mean? C. you did the other half, right? Okay, all of that, and then you'll have to go backwards.
I'm guessing it's.
So start with us, and then you'll have to do like, you'll make up the ones that we've already done. But if they're out of order, just like write me a note or something. Alright, so this problem instead asks us about what? How do you find the median?
You count up all of the numbers, you find the one in the center.
You find the one that's in the middle. If all I tell you is what the middle was, can I combine two classes and you tell me what the new middle is? No, because the way to think about it here is, I know that this one's bigger, but I have no idea if there were any numbers in this set between here and here, or the same thing opposite. So like, I don't know if that middle, I have no idea to know where it's gonna be. So you cannot combine to find median just from the original median.
Wait, can you say that one more time?
It's just the way, like, it makes sense of how you undo it and put it together, like for me, because of what the equation is. When you're just saying middle and no other information, I can't just put middle and middle together and find new middle. Like conceptually thinking through how to do mean, it makes sense. Well, I just add them all together to have the totals, divide by the totals. But median, I would need more than that. So I
So
can't.
what does 47 measurements have to do with anything? Is that this, the 30 off?
No, so it would.
If you were doing with me, which is what?
And a lot of times you'll see a question just like this one, and it actually does ask for mean. And so you do this. I've seen some questions that ask for both, and it'll be like this one, but median could be down, like a combined. Alright, so this is the fifth problem.
So if we wrote something for that, can we just say like could not be determined with the
Combine, can't find combined medians without all the data. Alright, so number 12. This one I'm not at all surprised where it is. Both of them are normal, but all of our answers say normal, so I'm probably not even gonna look at that. So I just need to figure out what's the mean and what's standard deviation. So I've got X and I've got Y. I've got means and I've got standard deviations. My mean of X is 10 with standard deviation of 3. My mean of Y is 9 with standard deviation of 4. And we are putting them together this way. So when I find the mu, the mean of Y minus X, means pretty much all across the board for everything in our class work just how you would think they would. So how do I find the mean of Y minus X? Just subtract them. I take the mean of Y minus the mean of X. Mean of Y was what? Mean of X was? So that knocks out 2 answer choices. Now, here is where the issue would be, and this is something that, again, you didn't study before you did this or look up or anything. So when you are combining random variables, to find standard deviation, there are 2 rules that we have to follow. You said one of the rules is what? Combine as variances. And what does it mean to be a variance versus standard deviation? You just do what with it? Square it. What was our other rule? Always add. If I'm 5 feet away and I'm 7 feet away, I'm not all of a sudden going to be 2 feet away. So you always add and you combine and state a variance. So when I am doing sigma of y minus x, I want my y as a variance. So sigma of y squared. I'm adding in between, even though the problem is subtract. Sigma of x squared. But now I'm in variances, so how do I go back from variances to standard deviation? So I've got 4 squared plus 3 squared. 4 squared is 16, 3 squared is 9. Those add to give you square root of 25, which is 5.
So if you're multiplying and dividing, that means you just multiply and divide. You're multiplying and dividing and division.
Okay, so we didn't talk about multiplying different random variables. We only did with adding and subtracting. We multiplied 2, like, so we did something like 1 variable multiplied by 2 or 4 or whatever. I want to write that up. Let me make a note because I can do that one. I want to be more organized with it. Transforming. And I'll do this one tomorrow or the next day, but I'll write up like when it's additional file, like we got about that's your question. I'll do that one. Now, even if I wasn't sure how to do it, if I have a standard deviation of 4 and a standard deviation of 3, should I end up with a standard deviation of less than that? No, so I shouldn't end up with a standard deviation of 1. So you should have at least been able to narrow it down between you. I'm trying to teach you how to at least narrow them down. Worst case scenario.
If you have a standard deviation of 3 or 4.
You're not going to all of a sudden have less variance, less standard deviation when you put them together.
Do you want us to go ahead and finish the test?
Oh, you're chapter 12 one. I'm not going to finish this question, but I'm going to start it. Actually, y'all wait 2 seconds. I'm going to talk about the one part I want to about this. I think this is the problem where I wrote beside of it, genuinely concerned about this. This is something that you will see on the AP exam, and it's not necessarily the question that's being asked, but the one thing that should stand out. We have 4 different types of samples here. Stratified is what this question is asking about. What's another one? Cluster, what's another one? Simple random sample, and another one that starts with S. Other than stratified. Starts with SY. Systematic. Sequence one. One of those 5 answer choices is basically the definition of one of those 4 sampling techniques. This is the definition of what? Of the simple random sample. And that is something that I can almost guarantee that you'll see on the AP exam. And so that is the answer choice because it's not stratified. But tomorrow I'm actually going to finish with this question and like actually talk about the 4 of them. I just wanted to end there.